All right, chapter 9 deals a lot with correlation and causation. Be very careful when you look at an equation and you say that x causes y to happen. No, x and y are just correlated, meaning they have some relationship with each other, hopefully. Maybe it's a very close relationship, that one follows the other very nicely, and then maybe it's not. Okay? So correlation, simply, if you look at the root of it, it doesn't mean correlate, right? Or some relationship between, well, the two variables, it probably should say, instead of two. It's the wrong homonym there. It should be TWO. Normally we talk about x and y, but it's how do they relate? How do they work together, or do they not work together? And then there's some terminology that I have written here for you. A lot of times we write that relationship as ordered pairs, x and y, where x is sometimes called the independent or explanatory variable. Okay. I sometimes look at that as a lot of times it's the input, right, into some equation. And y is the dependent, depending on what x, y would come out, or sometimes the response, kind of like the output. Like you put x in, what comes out, right? That's a lot of the ways I look at it. But I do believe that a lot of texts and a lot of questions would use explanatory and response. Okay. So x is kind of explaining the response y gives. You look at it that way. Okay. And so a lot of times a way to look at how two variables might be related, a very easy way is, and probably a very common way, is with what's called a scatter plot. Okay, and we see as these values are put together, what do they look like? Now this first example that we have on the next page, we could easily do it by hand, right? We could sit there, graph an x-y axis and do it by hand, but then we'd have to do all the calculations by hand as well. And some of these calculations are a little bit overwhelming. And so what we'll do is we'll use the technology, we'll use the graphing calculator. And so let's find a scatter plot and determine whether there appears to be a positive correlation, or maybe a negative, or maybe there's just no correlation at all. And notice what we're asking for first is a linear correlation. What does that mean? That maybe these points kind of line up, right? They make a line. Now, is it going to be perfect? No. Okay, but if they're kind of going like this, would you say that those are kind of lining up? And what would you give a slope to that line that you see in there, positive or negative? Positive, correct? So that would be a positive linear correlation. Then what would a negative one look like? Well, you'd go the other way, exactly. You'd be going like this. So what would it mean, no linear correlation? What would that look like? Yeah, it's all over the place, right? It's just put points wherever you feel like it, right? Now what if I put these two together that you see here? Does that appear to be a linear correlation? Would you have a good word to describe what correlation you believe you see there? Parabolic, and it's a lot of times called quadratic. Right? You could see kind of a parabola fitting in there fairly well, right? And we're going to stick with linear in here, okay? Because just imagine, linear is tough enough. We don't need to be getting to quadratic. So here are your values. So what do you suppose we're going to do with our technology to get some kind of scatter plot? What should we probably do? Well, we have to tell our calculator these points somehow. Lists, there you go. You're starting to learn, and I think this is one of the first times we've actually used the lists extensively, right? But you're starting to learn that they can be very powerful. But please don't forget, we've used them a lot, so it's probably something very smart to do first. Go in and clear them, right? Because we don't know what's down there, right? So clear, again, is at number 4 there. And then, can't you do several at one time? Didn't we do that the other time, right? And then you just put a comma between them, right? And it looks like we only need 2, right? We need an x and a y, so let's just do those 2. So list 1, list 2, and clear them out of there. Oh, done. Excellent. So let's clear that. And now let's go in there and edit, right? Oh, well, we did have some stuff in there, didn't we? Okay. So I normally just go down one of them. Make sure you hit enter, though. And make sure you check them when you're done. Make sure they are the correct values. And again, notice on this last one, if you don't hit enter, it's not going to put it in there. So make sure you do hit enter on that last one. And I believe just the right arrow takes you right up to the next one, and you can enter those in. Now do keep in mind in our table, these are both of thousands of dollars, right? But we don't need to imagine how much we'd have to change our window to graph this if I put in all those zeros, right? So we kind of truncated them all so that we can see the data easier. Again, make sure I'm doing it right as well. Make sure I have the right values in there. Well, they're at least ending at the same spot, so that's promising, right? Okay, so there's your X and your Y. Awesome, now what? And again, how did we know where to put what? How did we know which one was the explanatory and which one was the response? Just because I gave it to you in the table that way? Is there any guarantee that's always how it's going to come out? So I find it funny that all of you just started just entering it however you wanted to. But realize when you go graph, couldn't I make L2 the X values and L1 the Y values? I could, right? So that's fine at this point. But now we might have to talk about it. Well, let's see. It's advertising expenses, right? And then company sales. Well, don't you want to know the correlation between how much money you spent on advertising and how much money you get in result? So do you see how the sales is the response from how much I'm giving out, right? You see how that does actually work out as X and Y, or explanatory and response? Okay. All right. So now what? Any ideas? Well, we don't need to be in there anymore, right? We entered all that. Well, this screen's very blank. Yeah, we're going to go to stat plot, actually, which is right above the Y equals. See a second. And you may notice sometimes if your calculator's not graphing for you, it might be because of one of these is on. So go and turn it off. But as you can see, this plot 1 is off. It says so right there. Well, we should probably turn it on. I think you can do that just by hitting enter, and then you can go into plot 1. Well, we definitely want to turn it on. So on. All right. Well, what type of graph would I like? So you go down and say, well, what does that appear to be? Oh, that's scattered, just a bunch of points everywhere, right? And then the next one is they connect them, right? The next one's a nice bar graph or your histogram, right? This is a box and whiskers. That's like an inverted box and whiskers, or that's the one that's selected right now, right? And then kind of just another connected one. I think we'll go with that one. Actually, that last one looks like a step function. Okay, so that's the type I want, a scatter. Again, you choose one of the 6. You can't choose multiple ones, okay? An X list, or our explanatory variable, did we put that in L1? We did. Our Y1, or our response, did we put it in L2? We did. And now down here, you just have to decide, what do you want each of them to look like? I don't know. You want to start, you can always do whatever you want. You can always come back and change it. Should we start with big old squares or rectangles or plus signs or little dots, whatever you want, right? That sounds fine. Well, now what? Oh, go to graph? Well, what happened? Look at that. I got a bunch of stuff popping up. Oh, I got stuff in Y equals. Oh, yeah, okay. So let's clear that out of there. All right, now let's hit graph. I still don't have anything. Well, this is worthless. Why don't I have anything? Any ideas? Look at your values again. Those are coordinates, correct? X and Y values, ordered pairs. Yeah, they're way out there, exactly. So are they graphed right now? Yeah. Where are they? Way up. So how do you fix that? Well, yeah, let's go to window and look somewhere else, because the window I'm looking in right now, -10 to 10, is not helping. So let's look at our X. What do you think's a good idea for that? 0 to 3, something like that? Sure, let's do that. So 0, that sounds very, very feasible. 3. X scale, that means how often you want it to put a tick mark. Does 1 seem all right? Or you could do a half or whatever you wanted to. I'm good with 1. What do we want for our Y min? What's one of our lower ones? You know, 180 is kind of, so should we do like 175 or something like that? 175 seems acceptable. 2, what's our highest? 2, so should we go to maybe 250 maybe, just so that we have some room, right? X scale here, that'd be a lot of tick marks, huh? Maybe do 10 or something like that, or 5 or whatever you want to do there. Because I don't need tick marks using up my whole screen, right? And so resolution, don't worry about that. And do you even have it on the 83, the resolution? You do? Okay, yeah, don't worry about that. Well, now let's see. Oh, well, now we have some stuff. Just hit graph again. Well, it seems as though we're still not seeing some stuff. Did I hit the wrong values, maybe? What did I hit? Did yours work out? I'm wondering if some of mine are on top of each other. How many do we have? I've got 4, 5, 6, 7. And how many are we supposed to have? All right, well, let's check our window and see what's going on. 0, 3 seems okay, right? And we did 175. Do we have any below 175? Nope. And then we go up to 250. Well, I'll expand mine a little bit and see if maybe the box is just too big and it's not showing up. And let's see if this is a problem. We'll just send that back to 1. Well, I'm going to go check my lists then. They're all entered correctly, right? I'm wondering if some of them are too close to each other, though. Like these two right here. 186 and 184 might just be too close to each other, and it couldn't graph two big ones. So just put 1 in there. That would be my guess. Does that affect our looking at this and seeing if there's a linear correlation, though? No. What do you think? Is it linear? Yeah, pretty good, right? I mean, it's in there actually pretty decent, because you could see a line that kind of fits right in there. And that's eventually what we're going to work at is the best line to fit in there. And yeah, so what would you say, positive or negative on that one? Definitely positive, right? Yeah, it's increasing. So you look at it this way. I look at it this way as x is doing something, y is doing the same thing, right? So that's a good linear correlation. And in this case, if it's increasing and increasing, that means a positive, right? Okay, so that's good. Okay, any questions on that? All right. Well, now you might want to reset your window, but it's up to whatever you want to do. Or we can take a look at the next one here. So a student conducts a study to determine whether there's a linear relationship between the individual's weight and the daily water consumption. They're listed right there. So what do we do, like lots of lists here? Or do we still have just 2? Yeah, just going the other direction, right? Now, which one's like the explanatory and which one's the response? What do you think? Which one's input or explanatory and which one's output or response? Water is the input? Yep, very good. So that would be X or Y for our purposes. X, right? Yep, and the weight is the response. Yeah, don't always think that they're going to put them in order like that for you, okay? So go ahead and enter those, and I will do the same. Hopefully, they're far enough apart this time that our calculator will not struggle. And so again, you might want to clear that list. I don't know if we need to this time, but I'm going to anyways, to be careful. All right. Whoop. Almost made a big mistake there. Again, we could do this all by hand. Whoop, almost made another big mistake. There we go. I better check all these because I had some issues there. Oh, looks good. Okay. Now what's going to do, looking ahead, what's probably going to be an issue here? Yeah, the window's probably going to be an issue again because these points are nowhere near where those other points were. So try and find a window that seems acceptable to you. Again, we have a couple that are pretty close, so that might be a slight problem. But the X values, or the explanatory, are a little bit different this time. Where last time the explanatory and the response were both very close, which made it a little bit harder. Again, make sure you hit enter on the last one. or you do run into some problems with that. So where do we go again to get, yeah, stat plot. Now really, we still have this one on, right? And isn't it a scatter plot with list 1 and list 2? Kind of, so that's actually pretty good, right? So we can actually just go right to the window right now before we even graph it and change that. So what do you think for our explanatory, which is x, what would be a good values to choose? 20 and 90? I think that covers them, doesn't it? Yeah, I think that's a good value choice. 20 and 90. Yeah, probably 10. We don't need tons of tick marks in there, right? And then what do we got for y? Are these good? Well, not really. 100, that sounds really good. 100. We're giving the calculator enough room to do what it wants, right? 10, yeah, that's probably good, or we could probably even done whatever we wanted to there. And again, you could always go and change the big box and just make it dots or plus signs or something. Maybe I'll I'll go do that so you can see what that looks like. Maybe we'll try a plus sign this time. Yeah, it's like some of them are trying, right? Some are trying, right? But then there's those two kind of up above, right? They're kind of really throwing things off here, aren't they? The ones at the bottom seem like they're almost trying to do a negative, right? Yeah, but those two up there just throw everything. This isn't even quadratic, right? This is just whatever, right? Okay. So I would say that there's probably no linear correlation here. Okay. Now that's just a visual representation, correct? Obviously, at some point we're going to have to do a calculation on this to figure out if there is or not. And that's when math will come in, but we first have to figure out what correlation means, right? So any questions so far? All right. I don't believe you have this on yours. Maybe you do. Do you have something on the back? No? Okay. This is just something for us to look at then that is historical. I'm sure you're familiar with Vietnam. Nixon basically said that they were going to draft people. So they had to figure out how they were going to draft people. And so if you were born between January 1st, 1944 and December 31st, 1950, you were possibly going to be drafted. But what they did is they based it on your birthday. So if your birthday was January 1st of any of those years, you were number 1. Okay? If you were January 2nd of any of those years, you were number 2, so forth and so on. But then they figured, well, we can't just draft. Just because you were born on January 1st doesn't mean you should automatically get drafted first. So they figured out, well, let's take 365. I actually think they took ping pong balls, all numbered 1 to 365, and they put them in a bin, and they selected them out. The first ball that came out is almost like bingo, but in a bad way, right? The first number that came out, I think it was 300 and something. Then anybody born on that date, you notice why they choose 365, right? Anybody in any of those years born on that date would be drafted first, so forth and so on. That's how they did it. Okay? But in years since then, there has been some issues. So the first capsule that came out was September 14th. So anybody born on that date in any of those years was drafted first. So here is a scatter plot, fits today's, right? A scatter plot of the drawing. So this is the day of the year, so you can see 0 to 365, right? This is the order in which they came out. On the y-axis, that's the response, right? You see that? Explanatory is telling you what it's all about, right? The x. So that's the day of the year. And then the response is the order in which it happened. Do you believe there's any linear correlation there? Seems kind of all over the place, right? Well, what we're going to work on is looking a little bit closer at these. Does there seem to be big voids? Because really, if this was completely random, wouldn't we expect kind of all the spots to have about the same number of dots in them? Do you see spots that are maybe a little sparse, or spots that are maybe a little bit too dense would be a word we could use? Where are some spots that you see are a little dense? Or too much there? So have you noticed any spots that are 100? So which one are you looking at? Day of the year or? So kind of the top left, you're saying? It's kind of dense? Okay, so what does that really mean? Being dense up here, what can you give me like an explanation? Like, what does that mean in the context of this problem that it's dense up there? Yeah, they were the last ones to be chosen, right? So if you were born somewhere in this span, you really kind of were chosen late, correct? Any other spots that are dense? Bottom right. So what does that mean in the context of this problem? Yeah, so if you were born later in the year, you had a way better chance of being picked. And they actually did some statistical work on this, and it was not random. It was very flawed. Because what they did is they took the boxes, they had them all stacked. What was the first box they put in was January, and it got spun around. Then they put in February numbers, because they had to make sure they had all the numbers, right? And then they put the box. And so what's the last box that went in? And apparently they didn't let it spin around very much, because they just started picking. And who's going to be right on top? Later people in the year. Okay, so there was a huge flaw in the way that they, and obviously for those families that was very traumatic. And now they hear that, wow, they just put a bunch of balls in there and then that's how they picked it, and they didn't mix it up. So obviously you could understand people possibly being a little bit mad. And then just look at this whole, does this make sense then? Being kind of void of a lot of dots. Does that make sense? That whole line right there being void. Yeah, because if you were later in the year, you were already picked. And if you were early in the year, you weren't going to get picked as one of the first drafted. Okay, so very, very interesting. And we could possibly, if I have time, we'll take a look at the analysis they did and showed how far off that was from a random sample. But at first glance, looks pretty good, doesn't it? It's like, oh, sure, yeah, that was random. Yeah, not really. Okay. So any questions?